All right, so now we're going to look at some inverse and composites of functions with their inverse. So I've got 5x minus 1 as my f of x. Well, if I think about switching x and y, then I'd have x over here, add 1, divide by 5. So f inverse of x is x plus 1 over 5. Now f of f inverse means I'm going to have 5 times x plus 1 over 5 minus 1. Well, those 5's are going to cancel. Minus 1 plus 1 cancels, and I just get x. F inverse of f of x means I'm going to have 5x minus 1 plus 1 over 5. And again, this is just going to give me x. This is a feature of the inverse, that if I take an inverse of a function, I get out x. If I take a function of an inverse, I also get out x. We call these kinds of functions identity functions. So any function where I put in x and get out x is the identity. So let's show that f of f inverse is true for this rational function. So I'm going to start by solving for the inverse. So I'm going to get yx plus 2x equals 1. So then y is going to be 1 minus 2x, divide by x. And that is a function, so I can call it f inverse of x. So now f of f inverse, 1 over 1 minus 2x over x plus 2. Let's simplify that. So this is my f of f inverse. All right, so I'm going to multiply top bottom by x. And I'll get 1 minus 2x plus 2x, because I'm multiplying this by 2x. That's going to cancel, and I get x. Let's try the other way, f inverse of f of x. So now I'm going to take my f of x and plug it into my inverse. 1 minus 2 times 1 over x plus 2 over x. All right. If I want to simplify this, I'm going to multiply top bottom by x plus 2. So I'll get x plus 2 minus 2 over x times x plus 2. And up top, I'm going to get x over x will cancel, and I'll get 1 over x plus 2, which does not, in fact, give me x. Oh! Because I didn't substitute correctly. This x should have also been substituted for 1 over x plus 2. So then if I multiply top and bottom by x plus 2, then my denominator will just be 1. So now I am left with just x. Phew! So any function, so this is always true, that f of f inverse of x is always going to equal f of f inverse of x, and it should always equal x. So if you do a composite and the result is x, well, one of those functions is the inverse of the other. It's a nice way to prove inverses. Hint, hint.